Hello everyone, and welcome back to my YouTube channel. Thank you for the likes, thank you for the subscriptions, thank you for sharing the video if you have shared the video. And if you are here for the first time, make sure you hit the like button and subscribe to this channel, and make sure you turn on the notification bell icon for future updates. All right, and also don't forget to share this video with your technician friends that are still struggling on how to use a multimeter. All right, in the previous video I showed you how to identify what a diode is, how to identify diode on the PCB, and how to read diode with your multimeter, and also how to identify a bad diode on the PCB. All right, so if you have not watched the video, make sure you go there and watch the video. All right, don't forget to hit the like button if the previous videos has really helped you, and also if this video helps you, don't forget to hit the like button as well. And today we are going to be talking about resistor. Okay, what is a resistor? What are the types of resistor? How does resistor works on a PCB, on the phone PCB, or on a cell phone PCB? All right, so we'll be concentrating more on cell phone PCBs tonight, but I'm going to show you also on other boards how to recognize a resistor, how to read a resistor with your multimeter, and how to know a faulty resistor. Okay, so guys, follow me and let's begin. All right, what is a resistor? A resistor is an electronic component that creates resistance in the flow of electric current. Or you can also say that a resistor is an electrical component that limits or regulates the flow of electric current in an electronic circuit. And resistors are measured in ohms. Okay, we have ohms, we have kilo ohms, we have mega ohms. So I'm going to be showing you all these as we proceed in the video. Ladies and gentlemen, don't forget to hit the like button and subscribe to this channel now. All right, so starting from the types of resistor, we have fixed resistor and we have variable resistors. Okay, and a fixed resistor is a resistor that the value cannot be changed. All right, the value cannot be changed, the value is still the same, it can be changed. And a variable resistor is a resistor that the values can be changed. All right, the value of the resistance can be changed. I'm going to give you examples. All right, so stay tuned. All right, so now what are the importance of resistors on the PCB? Like I told you earlier, resistors are that are component that resist. From the word resist, they restrict current, certain current from flowing. Do you understand what I'm saying? It's like they are going to sieve the current and allow the ones that we need, that the voltage or the current that we require to pass through. I hope my grammar is not confusing you. All right, so what are the importance of these resistors? Number one, they limit electric current. As I said earlier, they limit electric current to flow. All right, they limit. Also, they divide voltages. You can use a resistor to divide voltage. I'm going to show you just shortly. Okay, we can also use a resistor to generate heat. All right, we have a lot of importance of resistors. Okay, we can also use it to gain control. We can also use it to set time constants. All right, and also many more like that. All right, like I told you, the fixed resistors are the resistors. Let me show you. I told you the types of resistors we have. We have fixed resistor and we have variable resistors. Okay, so let me show you how fixed resistor looks like. All right, we have fixed resistor on several PCB. This is a charger PCB. Okay, these are resistors. They are fixed. Okay, they are fixed and the values cannot change. They are fixed. They are fixed. All right, this one is fixed. They are fixed resistors all around this PCB. All right, on this PCB, okay, these are fixed resistors. the values cannot be changed. The values are constant. Okay, this one is a resistor, this is a resistor. So when you see things like this, they are resistors. This is a resistor, this is a resistor. Okay, they are fixed resistors. Okay, and on phones, on mobile PCBs, this black stuff here, this tiny stuff, these small things here, they are resistors, and they all have their values. Okay, so that's how to identify resistors. You see right here, these are resistors. Okay, they are very easy to identify. These are resistors as well. We have a lot of resistors on the mobile PCB, and I'm going to show you shortly their importance. Okay, so I'm just trying to show you. This is a resistor as well. This black one is also a resistor. Okay, so those are fixed resistors. We have variable resistors. Okay, we have variable resistors. All right, on this multimeter, if you open this multimeter right now, you will see a resistor inside this multimeter. Okay, they're the one that helps you to determine where you move your multimeter. They will sense where you move if you move it high, it will go high. If you move it up, you understand. That's how the resistance goes. Okay, so we have variable resistor. Just have it at the back of your mind. We have variable resistor inside the multimeter. That's why it helps you when you change your probes, and when you change this thing all around, when you move it up and down, it helps to get the desired point where you want to get your stuff read. Also inside this multimeter, we have resistors. We have resistor. You see, this thing is controlled by a resistor. Okay, just have it at the back of your mind. So now, what else can we say about resistors? Okay, now we move to how okay, I spoke earlier about using a resistor to divide voltage. All right, first of all, I will show you how to read resistors. Okay, so you put your multimeter, like I told you yesterday, this is diode mode and also buzzer mode. You can see the two is right there. So when you want to read the resistance, you see where these K's are. These are kilo ohms. These are kilo ohms. This is a symbol of ohm right here. You move your multimeter here. This 200 ohm, 2000 ohms. This 20,000 ohms, 200,000 ohms. You understand? That's 200k ohms. This 2000k ohms. So it goes from the smaller to the highest. Okay, so you read your resistor from this, and also from this multimeter as well. The same thing applies. You see all this 200 here, k, 20k, 200k, 200 mega, 20 mega ohm. Okay, this mega ohm, I told you we have ohm, kilo ohm, and mega ohm earlier, if you remember. So you can see on this multimeter is written ohms. So right there, that is where you take your resistance reading or resistor reading. Okay, now putting our multimeter on this, so it's better to put your multimeter on the higher side so that you can get the accurate reading of resistor. Or if you are very sure of the resistance of the resistor you are reading, then you can put your this dialer, you can put it wherever you want to put it. Okay, now I'm going to start reading the resistor on this PCB, then we'll go over to the mobile PCB. All right, let's take readings on these resistors. So reading resistor, it doesn't matter where your probes touches. It doesn't matter where your probes can touch any part of the resistor, any points, I mean any end of the resistor. So taking this resistor reading, I've put my dialer right on 20k. You can put it on 2000, it doesn't matter, but the value of this resistor will determine. But I'm very sure the values of this resistor are more than 2000, so I'll put it on 20k so we can get some reading. Okay, so I'll put it right, my red probe here, black probe here. Then you can see the reading is 5k, 5.01k resistance reading. That's the resistance reading. So even though you switch your probes, the black probes comes here and the red probes, and the red probe comes here, it's still going to give you the same reading. Do you see that? It still gives the same reading. So it doesn't matter how you put it. The second one, the value, that's 5K. Okay, this one is 0.4 ohms. So as this one is reading 0.4 right now, we can easily put it on 2000 to get more accurate reading. Yeah, this thing is painful. As you can see, that's 449 ohms. Okay, 449 ohms. So if you put it on this 200, it will not read properly. It will not give you accurate reading because 200 is less than 400. So that's how to read. Okay, and I also I said that resistors are used to divide voltage. Take a look at this PCB. Okay, on this side you can see we have 12 volts, which is this pin here, and also here 12 volts, which is this second pin here, and this one is 12 volts, which is this third pin here, and the next pin is G, which means this one is ground. Or this next pin is ground, and this next pin right here is 5 volts. You see 5V, that's 5 volts, 5 volts and ground. So you might be asking, how come all these voltages are on just one port? Okay, it's because if you switch from the back side, you see the legs. This is the side of the 12. 1 2 3 is the side of the 12 volts, and 1 2 3, no sorry, 1 2 here. You can see this pin and this pin, they are 5 volts. Okay, so these are the resistors that breaks the higher voltage coming from this transformer. They break it down to 5 volts. That's why you get 5 volts here on this side, and the resistor here breaks the voltage down from this transformer to 12 volts. So that's why I told you resistors can be used to divide voltage. You can see it divides the voltage. They have the same terminal, but they have different voltages. The output voltages here. So that's the work of resistor. All right. Hope you guys are getting me, and I've showed you how to. This meter has removed though, and I have showed you how to read these things on using the multimeter. So I hope you guys understand that. So now moving to the cell phone, because this multimeter is broken now, the probe, one of the probes is out, so I'm going to be using this one. Okay, all right, putting our dialer on 2K. So I told you we also have resistors on the PCBs. Okay, this is how resistors looks like. You see it's very black here, and you can see this is a resistor, this is a resistor, this one small one here is a resistor. It's very easy to recognize, to identify resistors. Look at a resistor here, it's also a resistor. This one is also a resistor. Okay, they are called SMD resistors. Okay, these ones are not SMD resistors, these ones are ceramic resistors. So these ones are SMD resistors. Okay, they are everywhere on the PCB. So the same way we read the resistance of the resistor of this PCB is the same way you read it. It doesn't matter where the probes are. So turn your dialer to whatever you want it to be if you are sure of the value. Do you understand? So you put your, okay, let me look for one resistor so I can read. I think there is a big resistor here. Oh, sorry. Let me get, okay. Let me read this one. Okay. There is a resistor. Putting my probes here. Okay, red probe on the left and red probe on the right and black probe on the left. And the reading, look at the reading is giving me on the multimeter. That's 0.16. That's let's say that is 500 ohms. That is 516 ohms. Okay, that's 516 ohms. So we have different values of resistors like that. All right, on the PCB, and they are very They are all playing their different roles. I told you earlier they restrict voltage, certain voltages, and they allow certain voltage to pass through at the other end. Do you understand? That's the work of resistor. They resist voltage. So if you have high voltage and you want to step it down, I hope I've been able to explain to you how it reduces voltage from here. You understand? This transformer carries a bigger voltage, but it steps it down to the required voltages that we have here. Okay, so that's how to read resistors. Okay, that's how to read resistors. This is a resistor as well here, right here. Okay, so it can be fuse resistor. Okay, that's the value right there. So it can be fuse resistor. We also have resistors all over the motherboard. All over, they're tiny. I'm going to show you also in the schematic right now. Okay, all these ones are resistors. All these ones, they are resistors. You see them? Resistors, resistor. There's another one right here. There's another small ones right here. Okay, so those are resistors. And how do you identify a resistor that is bad? Okay, you identify a resistor that is bad. One is either it's burnt, you see the physical burnt, or number two, it can short. Resistors can also short. Okay, and number three, it will not give the required, it will not give the actual reading. For example, if the resistance of the resistor is 1K, it will give you 200 ohms. If it gives you 200 ohms, that means the resistor is bad. If you take your reading with the multimeter, instead of giving you 1K and it's giving you 200 ohms, that means that resistor is bad. I hope you guys understand what I'm saying. So now let's take it to the schematics now. I'm going to switch off these lights right here so that you guys can see properly. Okay, I'm going to lift this a little bit up. All right, and we have several types of resistor. I told you we have fuse resistor. We also have thermistors. Okay, when you hear thermistors are also resistors. All right, I'm going to show you from the schematics right now on this Samsung Galaxy A20. All right, right now this switch. This is a switch of, as you can see here, if you guys are seeing me, this on and off volume. On and off volume. Now look at the PDFs. We have a lot of resistors and we have their values. Let me zoom it a bit. So if you want to know the value, the actual value of a resistance on a PCB, you need a schematic diagram as well to tell you the exact resistance of that resistor. Do you understand? For example, this one is, the resistor name is R5020. That's the number. Okay, but the actual value is what? Is 47K. So once you read this resistor with your multimeter, putting your probes, red probe here and black probe here, or black probe here and red probe here, it doesn't matter. Your multimeter should give you 47K. If it doesn't give you 47K, that means 47K means 47 kilo ohms. That means this resistor is bad. Instead of, if it's supposed to give you 47K and it's giving you 20K, this resistor needs to be changed. Do you understand? On the on and off volume part, you can see the schematic lines are right here. So, but this is a resistor. This is another resistor here. This is another resistor down here. This one is 47K. This is 47K. This is 4.7K resistor. This one that the arrow is pointing at right here, this black one, this is a resistor. Okay, that's how resistor looks like. So instead of, if it's supposed to give you 4.7K and it's giving you 2K, that means the resistor is bad. You need to replace it. So sometimes when the phone is giving you problem and probably the on and off button is not working, so the you have to check the resistors. Okay, also here, okay, you see the volume. You see on this schematic diagram, this blue line represents these blue lines that you are seeing here. So you trace it. If the volume up is having problem on your mobile device, you trace, you see this blue line is marked, the blue line, you go straight to this blue line, you check the resistors that is working on that line. Okay, as you can see, this power key, for example, if your phone is not powering on and you've checked the flex is reading normal, it's reading properly. You understand? You are very sure. So you see this red line, you come to your schematic diagram. This is like I said, this is Samsung A20 PCB. So you come to the red lines here, you read it, you look for the resistors around there. Okay, you see it was red, ne? Look at it, 1K. The resistor here goes to the terminal of this is the terminal that controls the power key. So if you come to this terminal and you read, you see the line goes straight to this resistor. So the resistor is supposed to be 1K, as you can see right here, supposed to be 1K. If it's not 1K, if it's giving you 20 ohms or it's giving you 500 ohms, that means this resistor is bad. You have to replace it. Or sometimes it will not read at all. This resistor will not read at all. If you put your red probe here and black probe here, it will not give you any reading. So that means this resistor is bad. I hope you guys are understanding what I'm saying. Now let's go to the resistance or value on the pad. Resistance value on the pad. So this resistor here supposed to give you 10 ohms. If it's giving you lesser value, or it's not giving you any value at all, that means this resistor is bad. You have to change it. Okay, this one now is 10K. This resistor is 10K. If it's not giving you 10K, it's giving you lesser value. If it gives you 9 point something K, the resistor is still fine. Okay, if it gives you 9 point something, so it's still fine. I hope you guys are getting me. So let me go to the thermistor now. We have thermistors on the board, all around the board, but not that much. But the thermistors, when we talk about thermistors, we have, okay, let me, the thermistor is also a kind of a resistor. All right, thermistors are like temperature sensors on the PCB, which sense the temperature of the phone if it's too high or it's too low, and sends the information right to the processor. All right, that's why when you go to the NTC of your battery terminal, the NTC sometimes is usually in the middle. The NTC is called the negative temperature coefficient. All right, it's called the negative temperature coefficient. And when the temperature is too high, when the temperature of the phone is too high, then the resistance will drop. The resistance goes down. Okay, when the temperature is too low, the resistance of the thermistor goes up. Okay, these are thermistors and they have values as well. This 100K. And let me tell you the very interesting part now. This is another thermistor right here. So let me show the thermistor of a subboard of this Samsung Galaxy A20. This is a thermistor of this board. Sometimes when the phone tells you temperature is too high or temperature is too low, this resistor is responsible. So when they tell you check the thermistor, when you hear thermistor, it means resistor. Do you understand? And it's also, you can also read it in K. So for example, if this Samsung Galaxy A20 is having temperature problem, it's either you change all this downboard or you call it subboard. Let me show you it is a subboard. You can see that it is a subboard. So you change all this subboard or you come straight to this thermistor. You come straight to this thermistor and you replace it, then your phone will be fine. I hope you guys are getting what I'm saying. So, and the value of this one is 47K. If it gives you 20K, the resistance of this resistor is bad. That means you need to replace this. Or if you read this, it's not reading at all. It's not giving you any reading. Okay? And this thermistor is always on the thermal line. It's always on the thermal line. We call something thermal line. Hope you guys are getting what I'm saying. So I don't want to waste much of your time. So that is all about resistor in a PCB. So resistor is very important on every PCB. All right, guys. Thank you so much for watching my video. You can also make more research on what a resistor is, on how to identify them as well. All right, thank you so much everyone for watching my video. See you in my next video. Peace.